Hi, this is Albert Garitham, and you're listening to Life's Potluck Buffet. Now, this is John Paulus, and you are listening to Life's Potluck Buffet, but it is a fact that algorithms are actually named after a person, not after a person named Albert Garitham, but, well, just stick around for today's episode and you'll see. Where we have to start today is if you open up a map, your favorite mapping program that has a map of the world. If you look at Western Central Asia, so where Uzbekistan and Turkmenistan are, if you look around there, you'll see there are vast amounts of arid steppes and deserty places. Now, have you gotten there? If you zoom in, you will see a patch of green. And if you're driving there, it's the A381. I don't know how the traffic is right now. It's kind of okay. It's middle of the night. So the area there is going to be of importance because that is the area from which we get the name for algorithms. But first, let's just clarify what algorithms are. If you don't know, I want to put it in simple terms. So I'm going to say they're sets of instructions that tell a machine, like a computer, how to do something that produces some output. That's it. Pretty simple, huh? So let's go back to the 9th century, and we find ourselves about a 30-hour drive, depending on traffic, from where we just were in those oases in the middle of the deserts of Western Central Asia. Remember, around the borders of Turkmenistan and Uzbekistan. And we are now in Baghdad, also known in English as Baghdad, and that's in the modern nation state of Iraq. But back then it was part of a vast, empire that stretched from parts of southern Italy and Sicily and the northern parts of Africa all the way around to where we started today in Central Asia. And in the 9th century, Baghdad was the bustling capital city of this empire. It's called the Abbasid Caliphate is the name of it if you want to know the details. But in the middle of Baghdad was an institution, a center, a research center, a library, and just basically an institution of learning called the House of Wisdom. And in the House of Wisdom were all sorts of intellectuals, but one who's really important to today because that's where we're going to find the guy who they named algorithms after. And that guy's name was Muhammad ibn Musa al-Khwarizmi. And the al-Khwarizmi part meant that he was from Khwarazm, which is that area off the A381 in Uzbekistan and Turkmenistan. That's what that refers to. And the al-Khwarizmi means the guy from Khwarazm. And he was a mathematician and astronomer. And it's because of his work and the popularity of his work in places far to the west of Baghdad that we have, what we call Arabic numerals, the very numbers that you look at every day, either happily, sadly, or indifferently. But the numbers that we have and the reason we have them is, this is the story about that too. Al-Khwarizmi wrote a book called The Compendious Book on Calculation by completion and balancing. That's how we translate it. But in that title are, well, one important word for our futures and one uh, definite article, al-Jabr. And al is the definite article, and Jabr, it's hard to translate, but in the context of the book, it means the kind of calculation that you do when you put something on the other side of an equation, like an algebraic equation. Oh, and see, it's al-Jabr. And when this was translated in places like 11th and 12th century England into Latin, it wasn't translated because the Latin translator was also probably like what is, I think the name was Adelard of Bath was the translator, and Adelard of Bath was probably like, I don't know how to translate this word. So Adelard of Bath just kept it as its original, just transliterated into Arabic as algebra. And algebra is where we get our word for algebra. And so when you learn algebra, that is where that word is coming from. And it's because, well, here's the thing. Before this time, before Al-Khwarizmi's works became popular, people who did not have access to the Hindu-Arabic numeral system, the one that today we easily recognize as what we just call numbers, before that there were things like abacus and charts and tables so that you can have large calculations with things like Roman numerals and Greek letters and all sorts of things that just are not that helpful. But the revolutionary idea that arrived from Baghdad, from Al-Khwarizmi's work, was that you can use these new numerals, which would be called Arabic numerals. They weren't new to, they were just new to the European world, but you can use them to do all sorts of mathematical operations without any struggles. No abacus, no charts, no confusing numerals, just an easy set of 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you could have any number you wanted in the world. And that was radical. And when these treatises of Al-Khwarizmi were translated into Latin, they would inevitably begin with the phrase Dixit Algorismi, which in Latin means Algorismi said. And then it would go on to explain all of these complex equations and functions and algebra and step-by-step instructions for arriving at solutions to mathematical equations. And all of a sudden, everything became a lot clearer. And so the Latinized name, Algorismi, became synonymous with numerals, equations, and these step-by-step instructions. And then when it came into contact with the Greek word arithmetic and arithmos, the Greek word for number, something fascinating happened. The algorismi became algorithmi. Because the people who knew about the Greek name for number and this new Arabic word that was actually a name of a Persian man from Khwarazm in Central Asia, those people changed the sound of the name algorismi to algorithmi, and then you had algorithm. And this algorithm And this idea of having a sequence of instructions to compute something was known well by the daughter of another famous person, an English nobleman by the name of George Gordon. And he was Lord Byron, a famous poet, and also participated in the Greek revolutionary efforts in the 19th century. And his daughter was a famous mathematician named Ada, the Countess of Lovelace. And Ada, Countess of Lovelace, wrote an algorithm that could be used by what she called an engine to compute what are a sequence of numbers known as Bernoulli numbers. And that algorithm was the first computer program, and why Ada Lovelace has the distinction of being called the first computer programmer. And it all started because of someone whose family was from somewhere in those oases in Central Asia. So now, in honor of Muhammad ibn Musa al-Khwarizmi and Ada Lovelace, let's ask the cards to give us a card-generated solution to our questions about life and work. All right, so here we go. Yellow lemons, blue dumplings, magenta noodles. Cards tell us somethings. All right. And here's the top one. This one's tough to extricate. Here we go. It's card 15. Speak where you want to be and the way will appear. So when it occurs to yourself to say, I want to be X, say it to yourself and no one else, and then operate as if it were already true and be ready to say to others that it is true. So why not give it a try now and say it out loud? I want to be X. All right. And think about that for today. Come up with the solution. X equals what for you? Oh, this is a great card because, X is used in algebra as the variable that we're solving for a lot of times. So find out using algebra that we have Muhammad ibn Musa al-Khwarizmi to thank for. Using that algebra, solve your life for X. And I'll see you tomorrow on Life's Potluck Buffet.